A tangent line to a circle intersects the circle in exactly one point. So a tangent just brushes right past the circle. It doesn't cut through it. It only touches the circle in exactly one point. So it will not pass through the center of the circle. And it touches that circle at exactly one point, and that point is called the point of tangency. So line AB is tangent to circle C, and line AB has its point of tangency to the circle at point A. So here's an example. These are two circles that have the same tangent line. That red line L only touches circle F in one point right here, only touches circle G in one point. And sometimes the circles have the same point of tangency. The circles are tangent to each other. So the rule is when your radius intersects your tangent line at the point of tangency, the radius and the tangent line are always going to be perpendicular. A tangent line, L, is perpendicular to the radius at the point of tangency. So this can be very helpful because we love right angles and we really love right triangles. So keep that in mind. We love right triangles. We're going to use those to our advantage. So here's an example. We have this circle R and we have a tangent line. Line ST is a tangent line because it only touches the circle at one point, at point S. Line TR is not a tangent because it cuts through the circle. If it kept going, it would touch the circle in two places. It would like exit out the other side of the circle. So ST is a tangent line. SR is our radius. And we just learned that the radius and the tangent line are always going to be perpendicular at that point of tangency. So our radius and our tangent line right here are perpendicular. Oh my gosh, we just created a right triangle. And so I love right triangles. I can do Pythag to find missing sides on this right triangle. So I'm doing a squared plus b squared equals c squared, 15 squared plus 36 squared equals, I don't know what to do for C. I have this part out here, UT, this part that's outside the circle, that's X. But this is just blank. Oh wait, it's a radius. Since RS is 15, RU is 15 because it's a radius as well. And so RT, this whole segment, that whole hypotenuse, is 15 plus X. And so I'm going to do 15 plus X squared as my hypotenuse. 15 squared is 225, and then 36 squared is 1,296. And then here's the kicker. I am going to FOIL 15 plus x squared. So 15 plus x plus 15 plus x. 15 times 15 is 225. 15 times x plus 15 times x, that's plus 30x plus x squared. So that's the kicker. You gotta FOIL those. And then 225 plus 1,296 is 1,521. So since this is a quadratic, I want to move everything over to the same side of the equal sign. So I'm going to move this 1,521. I'm going to subtract it from both sides. And so now I'll have 0 equals x squared plus 30x plus minus 1,296. So now I'm going to try and factor x squared plus 30x minus 1,296. So that's a really big number. We wouldn't give you a number that big on a test, so don't freak out. But 1,296 is 24 times 54, and how convenient is that? 24 and 54 have a difference of 30. Oh, how nice. So this is going to factor to x plus 54 times x minus 24, which will give us x equals negative 54 and x equals positive 24. And you can't have a negative value that represents a segment, so x is 24. So again, these numbers ended up being really big, so don't panic that we would ask you to factor and deal with a number that was quite that large.